is the different kinds of incompatibilities that might happen with pH meters. I don't know about you, but I didn't learn any of that in school. So it's really important for them to be very familiar with how an instrument operates, including something as simple as a balance in a pH meter. What they're doing here is comparing data for making a graph of pH versus millivolts to look at efficiency. And they're looking at each of their data and comparing it using standard deviation tools, using percent error tools for their weights, for their balances. So they're going really deeply in a really simple system into sources of variation and error. If you think about it, it's so basic, but here we've got one source of instrument error in the balance, as opposed to making a solution where you've already got three sources of instrument error: volume, balance, pH meter, not to mention the technician's error that's possibly in there. We think it's really important for students to think about this before they get to a complicated gene expression experiment. We do gene expression experiments, I just want to make it clear. We don't just stay on balances and pH meters, but this is a really important place to start for all of our students, whether they be post-bacs or associate students. What else are we seeing here? And this relates very strongly to what we heard in this morning's talks about vision and change. We're seeing higher order thinking skills at work. Now, there's a lot of video you didn't see. We had to go through a lot of video footage to get at even a glimmer of this. But they're questioning data. A lot of things that they say are things like, well, do we trust these measurements? It's really important that we understand what these measurements mean. So they're analyzing, they're interpreting data, and while they're doing that, they're gaining confidence in the basics of their data, not the fact that the gene expression might have worked or not worked. They're gaining confidence in all the building blocks that go into that. And this is quantitative reasoning, and that's one of the hallmarks of vision and change, and we think it's just as important as calculus. Well, actually, I think it's way more important than calculus, but that's another story. Also, they're working on communication skills. They're looking really critically at their data in the context of a group. So you can't be, shy and, oh, I'm too scared to show my data. You have to go ahead and put it out there, and you articulate your thoughts about your data. You collaborate. You give and you take constructive feedback over the course of the discussion. The process is inherently messy, like all learning is inherently messy. The discussions, if you watch enough of them, they're rambling. If you listen to them, it's really painful. I don't know how Lisa manages to keep her mouth shut through some of it, but she does, and I'm trying. But they get a lot of things wrong, but lots of times they keep going with the discussion until they get it right. So stuff gets fixed. In the middle of it, there's gems like, gee, I guess that temperature really does affect pH. Something you can tell them that till hell freezes over and they'll not buy it. But once they figure it out for themselves, they've got it. The benefit of this all is that they become conscious of what is meaningful in collecting data and what is not, about whether that, to 4 decimal places number they get off the spec, is that 4th decimal place really mean something? They have some really big aha moments. They develop that sense of what's important before they get to a system that's so complicated that weaning out what is important in a gene expression experiment or protein expression experiment is really impossible to do. They understand what factors they can control. They can understand what processes might be amenable to process control. So it leads them into a kind of a quality environment. And the 3-second vision and change, I just copied these down from this morning's presentations. The ability to apply the process of science, the ability to use quantitative reasoning, the ability to communicate and collaborate. And these are the reasons why we think that our students, through all these years, have been sought after. Our students are sought after over and over again, over a 4-year graduate, because they know how to do these things, because they come into the lab ready to question their data, ready to take criticism, and they know what they're doing in a lab. And students come back time and time again and tell us, well, what was the most valuable thing you had in the program? And they'll always say it was this class, even though while they're taking it, they might not, they're hungry to get to the gene expression experiment, but they also can recognize the validity of this.